Hello everyone, my name is Pritish. As you heard the initial introduction, I'm a technical architect with Benfico. We work in open banking and we have multiple products related to open banking and related regulatory requirements. Uh, so I'll not go too much in technical. I think till 5 o'clock today, we must have learned all the Java. Now with even India is trying now with India Stack, building some aggregation APIs and allowing fintechs to provide services on top of it. Similarly, across the globe, there are open banking APIs. So UK has its own version of open banking APIs. Europe has its own version. Similarly, Brazil, Saudi, now Qatar is coming up with its own version. And even World Bank is trying for the developing economies to come up with their own open banking specifications. So that's in a nutshell what open banking is. It involves four main key players in open banking. So there'll be obviously a customer, people like us. There'll be banks who will be implementing these open banking APIs. There'll be fintechs who are going to consume these open banking APIs. And then there are regulators who are driving this initiative in each respective countries. So in this particular slide, you will just see where Benfico or where we come in as solution provider for open banking. So as you know, all the banks have their own current existing bank platform. So they have their core banking APIs. Obviously, they are till now being used internal to their banking infrastructure. So they didn't expose it to the outside world. So they didn't care about all the financial API grade security compliance requirements. Now that they have to expose it to the outside world and everyone in the country who is authorized can access their APIs, there are certain security profiles. We'll cover in this session what security profiles are that they need to be compliant to. So that's where we come in. So we use banks' existing bank platform APIs. So because we are in Infosys campus, for example, Infosys provide these Finacle APIs for the bank's core banking system. So what we'll do is we'll take those APIs, we will transform these APIs into the open banking schema, protect them with the right security profile, uh, orchestrate the whole authentication flow that we need to do, and then expose those APIs to the fintech. And while doing this, we have to pass certain test suits. These are security conformance test suite, functional conformance test suite, etc. So that's where we come in. Here you can see some in the bottom. You see PhonePe, Google Pay. These guys are nothing but the fintechs. In each market, there are different fintechs. Like if you go to UK, you will see Token.io, you'll see MoneyHub, different players. They will try to connect to these APIs, aggregate the data, and provide the service. If I try to give a real world example, uh, for example, if I just gave this example the other day to a few people. So earlier, when you used to rent a flat in UK, you had to provide your 3 months transactions data. So how you do that is you go to your online banking, you download the 3 months transactions data, you provide the PDF, But now with open banking, last year when I rented a flat, I just gave a consent to a TPP to access my transactions data for 1 day. They access the transaction data. They found that everything is okay with my bank accounts and balance and everything, and they okayed my rent agreement. So that's one of the use case. There are a lot of other use cases that are coming up in different countries. So this is what open banking allows different fintechs to provide. Next, if we move on, this is the high-level technical architecture, how these APIs would be implemented. So we would have our own API gateway, which would validate all incoming TPPs. So all the APIs that we would expose, they are supposed to be exposed as per mTLS. So the TPP will come up with a certain open banking certificates. These certificates needs to be validated, not just like certificates validity, but we also have to validate whether this TPP is a regulated entity in the market, whether this TPP has the right role. So for example, a fintech is trying to call, let's say AISP API, accounts API, and they don't have AIS role in that particular country, then they shouldn't be allowed to call. So all these policies would be enforced on our gateway. The gateway would be connected to our IAM. So IAM is nothing but identity and access management. So that's what we use Keycloak for. Keycloak will have the full OIDC orchestration, and it will also have the identity brokering with the bank's identity provider to orchestrate the full authentication flow. The gateway will also be connected to obviously the Java APIs that we will build, the AIS and the PIS APIs, which will eventually connect to the core banking APIs and whatever the bank responds. So in this data integration that you see in the second point here, this is depending on what the bank has. So let's say the bank has SOAP APIs, then we will take the SOAP APIs and transform. If the bank has REST APIs, we'll take them and transform. And if bank doesn't have any API, they just have mainframe system or they have SFTP based setup, then we will take that and transform and return the response back. Now the critical component in this is Keycloak. So I hope some of you, anyone here has used Keycloak in your experience? Oh, so we have so many people, that's good to know. So as you know, Keycloak is a Red Hat sponsored open source OIDC and SAML supported identity and access management authorization server. So when we started, Keycloak wasn't compliant with all the open banking specification. So what we did is we made a special interest group for Keycloak, where we built all the compliance requirements for that we needed for the banking APIs. And now the versions that Keycloak you see has all the open banking compliance. You can just take the out-of-box Keycloak and it will pass all the FAPI and the security profile test suits. So that is what we have done in Keycloak. It's still ongoing. There are different RFC specifications that are coming in, like demonstration of proof and a lot of other things. So if some of you want to contribute, you can connect to me on LinkedIn. I can get you in touch with the special interest group and you can contribute there. The next I would like to highlight here is the consent APIs. So the consent APIs is nothing but, for example, when you make a UPI transfer, you are making transfer from bank to another bank. So there is no long live consent in a way. So in open banking, what you have is when you share the data with the TPP, you can give a permission for, let's say, I'll share the data for 3 months, right? Or 6 months or 12 months, right? So that's where the explicit consents comes in. So it's not just identity and access management through user credentials or OTP or second factor. There would be a explicit consent given for, let's say, 3 months, 6 months, etc. And any time in between, a user has a right to go and revoke the consent. If user revokes the consent at any time, the TPP should not be able to access the data. So all these would be done by our open banking platform. And as I mentioned, we need to validate TPP's authentication role, whether it is a regulated entity in that particular country or not. For all of that, we have a directory service. So that is another product of ours that we have built, where we fetch the data from all the NCAs in Europe. So NCA is nothing but a national competent authority. We aggregate the data, we list down who all are the regulated entities across the Europe in different countries. In that way, any incoming request, we can validate whether this TPP is valid or not, and then allow the call. apart from this open banking platform, we also work as a TPP as well. So we have another product where we ourselves are working as a TPP or an aggregator. So in that case, we call the banks, get the data, aggregate and show it on our portal and build services on top of that. So these are different products of ours and a high level overview. Any questions so far? Yeah. Yeah. So the security profile is different. So, but the most of the open banking security profiles are inspired from what UK first came up with, and they built on top of it. So, for example, UK has a base profile, and when Brazil came in, they said, oh, we want UK, but we also want encrypted request object with it, or we want pushed authorization request with it, right? So, anytime a new open banking requirement comes, there is a organization called OpenID. They publish the new FAPI test suite, and we have to make sure that we make Keycloak compliant with this. But now it is almost in autopilot mode. So any, because these are all small things now because the base is already there. So mostly it will be 1 or 2 days work for any contributor to just get that compliance. Any other question, guys? No? Okay. Yeah, so Swift is a different system. So here, for example, you always had a way to do payments, right? But for example, I'll give you an example for any card payment, right? So you were making a transfer from one bank to another, but there was a card involved. The card company is involved in between, right? So the transaction is going through that company. There is a certain amount that you are paying that company, right? Now, when UPI came in, that is gone, right? So similarly, in open banking, now it's the between the fintech and the bank, and it's user's permission. So user is saying, let's say there is a, in India also there are some legacy banks who are not good with technology, right? You're not satisfied with. No, for corporate customers as well. So this open banking is for both corporate and retail customers. So if bank has corporate customers, they have to implement the open banking for them as well. And obviously, depending on whether they are tier 1 banks or tier 2 banks, they'll have separate deadlines. But if they have corporate customers, then they have to implement open banking. Anything else? Okay, so as I explained in this diagram, the main integrations like data integrations, the PSU authentication, the consent integration. So the key challenges in the implementation, in case someone wants to join us or they want to work on their own on open banking, because I just read yesterday that I think Geo has in principle approval for an account aggregation and Open Money has it. So I'm assuming more and more players will start doing it in India. So the main points when you come with these implementations is the legacy system integrations. So if the bank has gotten these core banking services from a service provider, let's say 25 years ago, at that time the security and all these things were not that evolved. So this integration becomes a bit complex. The security and authentication, because now the APIs are exposed to the outside world. Most of the banks we have worked, even the tier 1 banks are not on their own, they are not FAPI secured. So to take that and build our solution on top of that and make it FAPI secured is bit difficult for us to achieve. The data standardization and interoperability. So in this, the specification is decided by multiple discussions and collaboration between a lot of players. But if the bank APIs don't have certain data, at times we also have to get the data from, ask the bank to build new APIs to fetch certain data from their systems, or they would also say that we will provide this data in some other, through other mechanism, and we need to integrate different ways. The scalability and performance, when it started, it was not that much used, but now we have millions of hits every day for our open banking platforms, at least for top banks. So scalability and performance is important, as it's not just one user. I could be one user, I could have 3 different fintechs and I can call my accounts. So if more and more fintechs come in the market, the API usage will keep on increasing. Consent management and data privacy. So as user has given long live consents, and there are offline tokens, longer tokens involved. We need to make sure that when user's consent is revoked by the user, the tokens are revoked, the sessions are removed, etc. So the data privacy is important. And error handling and user experience, because there are multiple TPPs, you have to send standardized error response as per the open banking specification for you to achieve compliance. So these are some of the key challenges in the implementation, both. So these I'm saying both on the TPP side as well as on the bank side, because we have both the solutions. The security principle, these are just standard security principles. I'll not go too much into it. These are just confidentiality, integrity. It is just mostly theory stuff. So I'll just go into the technical part of the security and how we achieve. So as we said, there are two parties involved here, fintech and the bank. There is a backend to backend communication between fintech and bank. So there has to be a strong client authentication for that. So in this case, fintech or a TPP is a client, bank is a server. So the bank needs to implement mutual TLS. When I say mutual TLS, the TPP will present their client certificate. Again, this is in each country, it is decided what type of open banking certificate TPP needs to have. So if it is, let's say UK, it should be OBVAC certificate. If it is Europe, it should be a EIDAS. These are different standards. If it is Brazil, it should be ICP V10 certificate. So depending on the country, the regulators decide this is the certificate TPP needs to acquire. Once they acquire, they will present that certificate. We'll validate this, obviously the validity of the certificate, but also the validity of the TPP, whether the regulated entity is still valid as per the central directory or the central bank. So this is the part of mutual TLS. All the backend calls, regardless whether it is a consent call or actual resource calls, are supposed to be protected by mutual TLS. The second is private key JOT. As most of you have used Keycloak. You know, Keycloak supports multiple client authentication methods, right? So when you configure a client in Keycloak server, you can just configure it with client ID and secret, right? So it's just like a username and password. So when you make a token call, you send a client ID and a secret in the request, you receive a token. But this is not allowed as per the financial API security guidelines. So because if your secret is compromised, your token is compromised. So instead, what it suggests is you use private key JOT. So in this way, what happens is the client would create an assertion JOT. So it would be a JOT which would be signed by client's private key. The authorization server will have client's public key. So when it receives the request, it will validate the JOT. If it is valid, then it will issue the token. Okay. So this is the minimum requirement for any open banking implementation. Apart from Europe, which they have, for some reason, they have not mandated, but UK, KSA, Brazil, Maldives, everywhere else, this is the minimum requirement. Enhanced authorization flows. So again, if you have used Keycloak, you know when you initiate an authorization flow. When I say authorization flow, when you hit an authorization endpoint, right? You send a request object. It's a JOT which has all the authorization parameters, right? Guys, most of you are aware of this, right? So you have an authorization request which has some request JOT which has authorization parameters. Now in open banking, these authorization parameters can't be a plain JOT, because if it is a plain JOT, anyone can take that JOT, open it in jot.io, or just base64 encoded, right? So you can decode and see the claims, right? So here you are supposed to either encrypt the request object or choose the pushed authorization request, where you make a call, register your authorization parameters with the authorization server, and then use the reference ID instead of sending the whole JOT. The third is mTLS bound access tokens. So what it means is when someone makes a token call, they will send a client certificate. The server, while issuing the token, needs to bind that client's thumbprint or the client certificate's thumbprint with the token. So when the actual resource call comes, they can validate that this is the same user who had made the token call. So if I give a simple example, if I am a client, I have a token, but someone else somehow get access to my token, they should not be able to use that token, right? So for them to use the token, they would need my client certificate as well. So that is what we mean when we say mTLS bound token. High assurance cryptography. So algorithms like RS-256 and others are not allowed. You need to use PS256 and ES256. Because you have long live consent, you need to have long live refresh tokens. When you issue long live, any authorization server that you use, if you issue long live refresh token, you need to have an industry standard authorization server, because if you lose out on sessions, if, for example, the sessions are not persisted in the database or something, uh, the TPP will have inconvenience, and then on the basis of that, they can complain to the regulator. So in this case, you need a industry standard authorization. You can't create your own authorization server with some basic functionality of OIDC. That wouldn't be good enough. Enable proof of key for code exchange. This is again in the authentication, in the authorization URL. The client and the server are supposed to do this. This can't be optional. The server has to enforce this. The next is user authentication and strong customer authentication. So when the request comes, you can't just take first factor authentication. You need to have first factor, second factor, have the dynamic linking with the consent to the OTP if you are sending. So all of that is required. So these are some of the key components of FAPI. I would just keeping time. How much more time I have? Okay, so I would just like to show some of the flows, how it will work. So just how when you do a transfer on UPI, because most of you use it here in India, but in open banking, how it would be is you are on a TPP's web-based solution or a mobile app, right? So you are a user of that fintech's app. So for example, let me just give an example of, let's say, Google Pay. So you are on Google Pay as a user. Now Google Pay will list down all the banks that you can connect to through open banking. So for example, if they have 50 banks in UK, they'll show 50 banks. You will select one bank, okay? And when you select the bank, in the backend, Google Pay will call whatever APIs it needs to call, and then it will redirect you to the bank platform. So this is the ASPSP is nothing but bank platform where it will authenticate the consent. Once consent is authenticated, the bank would redirect back to the TPP's redirect URL. And then the remaining calls will happen through back channel. So you'll have account payments, whatever call through back channel. The fintech can fetch your data and then build any services on top of it. So this is the general standard redirect strong customer authentication. Even if you have used Keycloak for basic purposes, you have used this. So when you have a portal and when you click on sign in, you redirect to an endpoint, right? So that endpoint is the redirection to the authorization endpoint. The same way it is working here. So to authenticate, you are redirecting to an authorization endpoint. The second one is the decoupled strong customer authentication. So because more and more people are using now mobile apps for the banks, so this is a decoupled flow. In this, there is no redirect. There is a back channel request that a TPP will send to the bank, sending users identifier. So for example, the TPP has my mobile number. It will just say that from this mobile number, the user wants to transfer 1,000 rupees, for example, right? The bank knows from the mobile number who is the user, and it will send the notification or a pop-up notification on the user's mobile device that are you authorizing the 100 or 1,000 rupees payment to this fintech? If you okay, then the authentication would be complete. So in this case, there is no redirect from the fintech to the bank platform. It's a decoupled customer authentication, something called client initiated back channel authentication, through which you can achieve this. This again is added in Keycloak by our community. So now SIBA is also supported, and it has all the FAPI conformance requirements. Next is the distributed strong customer authentication. These are just different types of authentication in case you need a maker checker flow. So the question that you asked, right? So if it is a corporate customer, they could have multiple users that need to authenticate the request, right? So in this case, you will have a distributed strong customer authentication. So the fintech would initiate a request only if one user has given the authentication. That's not good enough. So the fintech will only get a token that they can call once both the users have given the permission. So we call this maker checker flow or a distributed strong customer authentication. Now the data transmission, because that is what is happening between TPP's platform and our platform. And because we don't have the bank data, we also call the bank API. So there also there is a backend to backend call from our open banking platform to the bank platform. So the general key concepts that we need to keep in mind is we use HTTPS, just TLS is not enough. So we have to use mTLS. When we have mTLS, there are certain ciphers which we are not supposed to use. So there are only authorized ciphers that you can allow in open banking. So in your gateway, you need to mandate what all ciphers can be used. So that is what I mean when I say maintain up-to-date TLS configuration. Client-side certificate, mutual TLS, encrypt any sensitive data. So between our communication, between the bank and our platform, we have a standard security mechanism where we have mTLS, but we also have payload signed and encrypted. So what we'll do is we'll sign it with our private key and encrypt with bank's public key. And the same way, when the bank returns the response back, they'll sign it with their private key and encrypt with our public key. So it will always be a JWE. And along with the mutual TLS, this is the payload encryption is also there. For the communication between fintech and us, because we don't want any man in the middle who can manipulate the response or the request payload, there is a message signing requirement. So any request that we will receive, there would be an XJOS signature or a detached JOT that you will get in a header. So with that, you can identify that the request hasn't been manipulated with. So the integrity of the request and the response payloads is taken care of. The Java specific security consideration, you need to be clear with the JOT authentication. You need to know how to handle the JOT, what algorithm you need to use for the respective implementation. OAuth and OpenID connect, you need to have in-depth knowledge of how OAuth 2 works, what are certain things which are not permissible when you work with the financial APIs. Spin security with OAuth 2, you get this standard library integration, so that's pretty much straightforward. Validation of the token. So anytime you receive a request, apart from the mTLS bound access token, you need to make sure that you introspect the token. Just checking the signature of the token is not good enough. And last one is general validation that we have for vulnerabilities. This is pretty much all from my side that I wanted to cover. Any questions from anyone? Yeah, so as I said, that is driven by the respective central bank. So if it is UK, it would be FCA. If it is Brazil, it would be Brazil Central Bank. If it is Saudi, it would be SAMA. So every central bank is driving this in each country. And then if it is a developing country, then World Bank is trying to come up with a common stack, which each bank has to follow and implement. Even in India, we have. So India, like Reserve Bank and this NPCI and these guys drive. So. You mean the fintech and the bank? Yeah, between two different countries, no. So if the fintech is, let's say, authorized in both UK and Europe, then that fintech can make transfer on both the banks. So before Brexit happened, they had the rights to operate in both the countries, right? So after Brexit, they decided that they need to acquire new open banking certificate to operate in UK. But if if that particular fintech is authorized by FCA, that's a regulator in UK, right? So if FCA has authorized that fintech to operate in UK, then they can call the API. But each country has their own specifications. So yeah, if you take, let's say, Chase Bank, right? So Chase is operating both in UK and Europe, but they have to implement two different versions because UK has one version of API, Europe has another version of API. So the UK TPPs will call the UK version, the European ones will call European version. So that's how it is. Yeah, so that is why we use Keycloak. So the tokens are never saved. So what is saved is the offline session. So if you see now, the normal sessions are also getting persisted in database in the new version of Keycloak. So that is why I said when we have to use because that is already taken care of by Keycloak, right? Because the Keycloak is certified with all that. So you don't need to worry about it. If you are talking about, do we capture anything for the bank? We don't store anything for the bank, but so the access tokens are never saved. It's just the session. So when access token comes for validation, right? So access token is nothing but a JOT, right? So you validate the JOT is signed by our own private key, right? So that is one. The second is you check the expiry of the JOT, right? Because access token is always short-lived. So when I say long-lived token, in OIDC, long-lived token always means refresh token in general, right? You never give access token which is valid for 90 days. You always give access token for, let's say, 5 to 15 minutes, and the refresh token will be valid for 90 days. So if a TPP wants, they'll have to make a new token call to refresh it. Because if you give access token, then if that's compromised, then anyone can use it. No, so only the session part of that is saved. The token JOT as it is not getting saved. And you don't log anything. Yeah. So they will regenerate, but to regenerate the token, they will need their client certificate. They'll need their client credentials. So the token call itself, so the refresh token is the same token call, just the grant type is different, right? The grant type is refresh token. So you'll have to make the same call, same token call, but you just change the grant type to refresh token and send the refresh token in the request. Anything else from anyone? From my team? No? Okay. Yeah, so this is some interesting products on open banking that we are working on. If you guys want to know more about us or something, get in touch on LinkedIn. And if you want to be part of Keycloak community and open source contributions and things, then also you should reach out. We need more and more people. In India, I see a lot of people use Keycloak, but not many many are contributing. So I went to Keycloak conference last month, and they said the same thing. We have a lot of Indian community who ask the questions, but in terms of contributions, there are less number of people. So I think we should have more people. So maybe we can create our own special interest group and anything, right? Some of the use cases we may try and add, submit pull request, something. Anything else, guys? Nothing, then have a good evening. It's already too late. They are waiting for me to finish, so I'll finish. Thanks a lot, everyone.